Alright, here we are in 14.5, and our goal today is to find the volume of pyramids. So our key idea is the volume V of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So this looks a lot like the volume of a cone, right? And the only difference is going to be what the area of the base formula is. So what we plug in for our big B there. The difference between a cone and a pyramid is that the base of a cone is a circle, so we use pi r squared for the area of the base formula. And for a pyramid, it's a rectangle or a square, so we use length times width. So our expanded version will look like this for the pyramid. One important thing to note is that the height of a pyramid, so this measurement here, is the perpendicular distance from the base to the vertex. So this here is the vertex where all the sides meet, and the height is that perpendicular distance there that will be noted with the little corner that indicates a 90 degree angle. So that's really important that you know that perpendicular distance between the vertex and the base is the height. So do you think that base always has to be a rectangle or a square for pyramids? No, you could have a triangular prism, in which case this is going to change, right? If it was a triangle, you would have, let's minimize this a bit. If it's a triangular prism, you're going to have volume equals 1/3, but this is going to be the area of a triangle formula, which would be 1/2 base times height times the outside height. And again, this height in here, that's going to be the height of the triangle base, not the height as in the height of the prism, which is the distance between the vertex and the base. Let's look at this example. So we have our pyramid, and we know it's a pyramid because there's a vertex where they all meet, and then just the one base. So we have volume equals 1/3 area of the base times the height. We have 1/3. What shape is the base? It's a triangle, so it's going to be 1/2 base times height. That's the area of a triangle formula times the height of the whole thing. So we have 1/3 times 1/2. The base of the triangle is this here. So we have 17.5 times the height of the triangle is this here. So that's 6. And then this outside height, this is 10. That's the distance between, the perpendicular distance between the vertex and base, and that is 10. So then we multiply all that together, and we get 175 meters cubed. Got it? Let's look at another one. Okay, here's another pyramid, and it's a rectangular pyramid because the base is a rectangle there on the bottom. So we have volume equals 1/3 big B times height. 1/3, the base is a rectangle, so it's length times width times height. 1/3, 3 times 4, the height is 7. And we put all that together and we get the volume is equal to 28 feet cubed. Got it? All right, now you're going to try a couple. All right, so find the volume of these two pyramids, and go ahead and hit pause and solve those, and then we'll move on. All right, so here's a real-life application problem. The volume of sunscreen in bottle B is about how many times the volume in bottle A? So we have bottle A and bottle B. Which is the better buy? And use the formula for the volume of the pyramid to estimate the amount of sunscreen in each bottle. So this is us starting answering A. So we have bottle A. That says bottle A, I promise. And we have volume equals 1/3 area of the base times the height equals 1/3. We have 2 and 1 there for length times width. The height is 6. Oops, 6. So this gives us 4 inches cubed. That's the volume for bottle A. And shrink this a little bit and move it over. I'll move that over. Okay. Now for bottle B, we do the same thing. Volume equals 1/3 big B times height, 1/3 length times width times height, 1/3. And we have 3 and 1.5 there. 3 times 1.5. The height is 4. And when we multiply all that, we get 6 inches cubed. So the volume of sunscreen in bottle B is 6 inches cubed, and in A, it's 4 inches cubed. So if we divide 6 divided by 4, we get 1.5. So that tells us that bottle B is about 1.5 times the volume in bottle A. And if you were answering this on a test, I don't have the space, nor is it easy to write with my finger on this. So I'm just leaving it and telling you it's 1.5, but on a test you would need to write, so the volume of sunscreen in bottle B is about 1.5 times the volume in bottle A, and give me a complete answer. So now let's answer part B. Let's shrink all of this and move it over a bit. Now it's really small up there, but we can still read it. So, B, which is the better buy? So we want to find the unit cost for each bottle. So the cost, based on the drawing up here, bottle A is $9.95. If you look, it's really small up there. So I'll stick with yellow for bottle A. So we have the cost over the volume, right? Because that's going to tell us how much it is per 1 cubic inch. So we have $9.96 because that's what it gives us way up there in the drawing. And our volume was 4 inches cubed. And that simplifies to $2.49 per 1 cubic inch. I keep trying to make this smaller, but it's making the entire thing smaller. Sorry about that. Anyways, so for bottle B, we'll stick with blue, and we have the same cost over volume, and that is $14.40. It says way up there, really small, over our volume, which is 6 cubic inches, and that simplifies to $2.40 per 1 cubic inch. So, since bottle B is cheaper per cubic inch, the unit cost of bottle B is less than the unit cost of bottle A. Bottle B is the better buy. Got it? All right, so that's it. I won't make you try one of those right now. We'll do more in class. And just make sure you have good notes and examples written down.